Hello everyone. I hope you all will be fine, safe and healthy at your home, and I hope you all will be enjoying your online classes. So let us start our today's session. In our today's session I have brought the study of heat capacity. So let us start the study about the heat capacity. So first of all you have to focus on the point which I have written for you. So let us start to understand. So here I have written about the heat capacity. It is defined as the amount of heat required to raise the temperature of the system through 1 degree Celsius. Means the amount of heat which is required to raise the temperature. Means किसी भी system के temperature को 1 degree Celsius बढ़ाने के लिए whatever the amount of heat we need, that we call it, this is the heat capacity. So here we need to raise in the temperature, so we also call it, this is thermal capacity also. So it is to be denoted by C. C is equals to Q upon delta T, that we have to know. So here Q is equals to C into delta T. Here the C is what? Heat coefficient. Okay. Now, so let us talk about the next type of heat capacity. This is the molar heat capacity. So you see here what I have written, the amount of heat required to raise the temperature of 1 mole of the substance through 1 degree Celsius. So here we will talk about 1 mole of the substance. So here we have given the name molar heat capacity. So earlier we have written Q is equals to C into delta T. So here it should be multiplied with the M also. Okay. So because we are talking about the mole. So the next point which I just want to discuss with you, this is the type of heat capacity, and after that we will study what is the relation between different types of heat capacity. So here the first, it is to be of CV, means heat capacity at constant volume. So it becomes, as we have written there, C is equals to Q upon delta T. So if we are taking as constant volume, so CV is equals to QV upon delta T must be written. So as I have written, CV is equals to QV upon delta T. So that you can write CV is equals to QV upon delta T. Actually QV, that is equal to internal energy change. So we have got it, CV is equals to delta U upon delta T. Now the next, if we talk about the constant pressure, so in place of V we will write there P. So it becomes Cp is equals to Qp upon delta T, and at constant pressure the heat, that is enthalpy change, that will be equal to delta H. So here you can write in place of Qp, that already I have taught in the previous session. So Qp is equals to delta H upon delta T. So let us start to understand what is the relationship between Cp and Cv, means heat capacity at constant pressure and the heat capacity at constant volume. So you see here, first of all few points I will write. So as Qv is equals to Cv delta T, which is equal to delta U, that recently I have taught. Now as you can write, Qp is equals to, this is of Cp delta T is equals to delta H. Okay. So at in the difference, as I have taught in the previous session, the enthalpy is what? H is equals to U plus PV. Okay. So enthalpy is equals to internal energy plus pressure, volume, work done. So if we talk about ideal gas equation, so from ideal gas equation, what you have studied, PV is equals to nRT, that I have taught. So in place of this PV we will write there nRT. So we can write there H is equals to U plus nRT. Here I am telling once again, in place of PV I have written this nRT. Okay. Now for a change of the system, so suppose for a change if we are talking, so we will put there the delta. If we will talk about the change, so that can be written delta, you see here, delta H is equals to delta U, delta H change in enthalpy, delta U internal energy change. Now we can write del nRT. This is the difference in the moles of number of reactant product minus number of reactant. Okay. So now suppose, now after that what we have to do, if we will divide it by the delta T. So now delta H upon delta T. The whole equation is to be divided by delta T is equals to delta U upon delta T plus del N RT upon delta T. So here the temperature is also going to be changed, so delta T can be written. So here delta T to delta T will be cancelled. Delta H upon delta T we have got it, that is equal to Cp, and delta U upon delta T that we have got it, that is equal to Cv. So in place of this delta H upon delta T we can write there Cp, and in place of delta U upon delta T this is to be Cv plus this is to be of del N R. Okay, now we can write there Cp minus Cv, this is equal to delta N R. Okay, or if we are not writing there the change in the numbers of moles, so simply we can write there Cp minus Cv is equals to Nr, or if we are taking N is equals to 1, so we have got there the relation Cp minus Cv is equals to R. So this is the relationship between the heat capacity at constant pressure and the heat capacity at constant volume. I hope you all have got it, the complete detailed explanation about the heat capacity. That's all for today's session.